Good morning all, more post. It's Postbag. Right, let's start with this one. Something to do with audio connectors. So these are mono jack plugs to dual RCA phono, not stereo, but just dual, so that what I can do with the vocoder project, which on the front panel, these slightly larger holes are for 1/4 inch mono jack sockets. This whole project is mono, there's no stereo on here. So the mono jack outputs and inputs, but particularly the output, I want to split it so that I can put it into the stereo input of the power amplifier. So this is the speaker I generally use for my audio or music or sound type projects. It's convenient because it's got a built-in battery, it's got an aux input, which is like a line level input. It's stereo, there are 2 speakers in here. This is the one with the big passive membranes. But I'm only using 1/2 typically when I'm using the crocodile clips to connect a stereo 3.5mm jack to my audio source. So with these, I can split the mono audio output coming from the 1/4 inch jack, 6.35mm. I think that 1/4 inch jack originated in telephone exchanges, but it's used in guitars and music type applications. Yes, that mono can be split into 2 signals, which can then go into the stereo input. Now, I don't really think this can be used the other way. You can't really put a stereo output from something into here because these are just going to be paralleled up inside. So you're going to have one channel of audio fighting the other channel. You really need to mix it through resistors if you're going to do that. So no, this is for 1/4 inch mono output to stereo audio input. So this item is an audio Y splitter, dual 2 RCA female jack to 6.35mm, 1/4 inch male mono plug adapter. It was just 99 cents and free shipping, and that was from Elec Mal. Okay, on to this one. This is from the UK, from Birmingham. I think it's probably Banggood. They do seem to have a distribution centre in Birmingham, which means things get here quicker, of course. What's that? Right, this is a kit. I think I'm pretty sure it is because that's the ZIF socket. It's one of these component testers, but this one has a rotary encoder. Now this one has the rotary encoder, and that of course also has a clicky switch. So I presume they've dispensed with the click switch, and you press the rotary encoder and turn it to select the various functions. And I have noticed up here we've got ground and F in. Let's get in a bit closer. And this, I'm pretty sure, is for frequency measurement, which is on my other component testers, but it doesn't seem to be implemented in hardware. So take this one for example. This is a G328. If you press and hold, or maybe you have to let it boot first. Press and hold, it says selection. And if you come down to frequency, press and hold again, it starts measuring frequency and it flickers. So it's doing an update and it's measuring 0 Hertz. But I've tried putting a frequency into the test pins and it doesn't do anything. And I think what this is the firmware was updated on this unit, but the frequency input measuring hardware is not on this particular one. So this can't measure frequency. I think the software or the firmware in this one is probably pretty much the same, but this one does have the frequency measuring input circuitry. Right, now this kit's been kindly supplied by Banggood, so let's take a look at it on Banggood's website. So here it is. It's called Original Highland DIY M12864 Graphics Version Transistor Tester Kit. LCR, so inductor, capacitor, resistor, ESR, equivalent series resistance for capacitors, and PWM. This one's currently priced at $13.89 US. What's that in euros? 13.09. What's that in pounds? 11.15. Not much difference these days between dollars, euros, and pounds. Right, let's have a look further down the listing. So this unit has resistors, capacitors, inductors, diodes, transistors, SCR, that's silicon controlled rectifier. That's thyristor, I think it is. Probably also does triacs. And most commonly used devices, capacitance line measurement, capacity and ESR, square wave generator, PWM pulse signal generator, frequency meter function. So that's the frequency measurement. And a graphical display. Power input is 5.5 to 12 volts. And further down, there's this. It's a link to the manual. Right, I'm not sure why this is so big, but it is. It's a PDF coming from a Google Drive account, I think. Right, so it shows you pictures of putting the resistors on and all the other components and details, all the assembly instructions, but I want the bit about the frequency input. Oh, this bit's quite interesting. This is how to do the calibration and self-test. You basically link pins 1, 2, and 3 together with little link wires. Okay, on to frequency measurement. So here's the additional function frequency measurement. Now it said if the measured frequency is below 25 kilohertz, you get a resolution of 0.001 hertz. I think it can do higher than that. Yeah, here's a picture of the ground and F-in connectors. I think it can go higher than 25 kilohertz, but with reduced accuracy. I think that's what it said. So yeah, this will be a very interesting kit. I'll do a kit build and then probably have to follow that up with a video about doing various tests on this. I'll try and find as many different components as I can. Right, next up is this in a yellow pack. And this is, oh, it's a little voltmeter module. Now, if I remember rightly, this one has not only digits, rip that bag, but I think, yes, it also has a bar graph display. So let's put that on a battery. Now, it's intended for 12 volt lead acid, but let's start on 9 volts so that we can see what it does when it's a bit low. Well, that's interesting. These wires are just soldered onto the PCB on the underside. There's no connector, which is a shame really, because these don't look very resilient. A few waggles and they'll probably work loose. But okay, let's give it a try. Right, pause to pause. And that one's saying 8.73, which is very low for a 12 volt battery, and nothing on the bar graph. So let's get a 12 volt battery. Right, this is 12 volts. It's 10 of these Eneloop lights. It might be a bit over 12 volts. That is if it's making a good connection. Oh yeah, that's not too bad. 12.5, and we have some reds and some greens. And finally on a proper lead acid, what's this? Oh, I think the details are on the back. But that's a bit low, isn't it? 11.2 volts, and the bar graph is well into the red. And inside it's pretty neat. Although, of course, the displays are sandwiched in the middle, so they don't really, they're not using the full width. All the chips are coated in something, so I can't get any markings. But if I were to have a guess, I'd say microcontroller, HC595, possibly for driving the digits of the display, and for the bar graph, possibly something like the LM3914, the linear version of that LM3915 I looked at the other day. So this one is One Piece's charge level indicator voltmeter for 12 volt lead acid battery. It was $3.08, free shipping, and this came from Survey 2014. Right, this one I've jumped the queue a bit. This came in just this morning, but I'm quite excited about the power module. Yeah, it looks like someone's bodged together a big box out of smaller boxes. Right, this one's quite well packed, lots of bubble wrap and a box within a box, and it should be well packed because it wasn't cheap. It's a QD188 Alt QC. And yes, this is the new Kidian power bank to try and replace my favourite power bank, which is no longer possible to buy. Right, in the box, giant sized power bank, and also 2.1 to 2.1, or it might even be a 2.5 to a 2.1. Yes, I think that might be. Let's have a closer look. Yes, I think you can see that these are different internal diameters. So I'm pretty sure one's a 2.1 and one's a 2.5. Right, this thing is absolutely enormous, certainly a lot bigger than the QD184, which I really like to use. But this thing has a much better spec. I think it can go from, well, I think it's 0.1 volts output to 24 volts. This goes from 5 to 13. Let's just do a quick size check with a couple of other power banks. Right, QD184, 4 cells. This is the one I use all the time. This is the QD185, 5 cells. I had a problem with this one. It had a squealing inductor. Can't remember much about it. It was a long time ago, but I know there's a new one of these out now, and I'll try and get hold of that. This is the QD186, 6 cells, with a nice detailed, I think it might, no, it's an LCD display. This is the one I put the cell in back to front and blew it up, and it's never worked since. And this one is the one that's just come in, the QD188, which is 8 cells. Okay, let's have a quick look over it. On the front there's an on button and a down button. On the top we've got a USB 1, a USB 2, an out M, so that's the multi-voltage out, which I'm pretty sure goes up to 24 volts. And in DC. Now the spec of the in DC is quite interesting. There's also a micro USB on the side, so you can charge this from 5 volts, but of course it's quite slow because there are 8 cells in here. Right, this manual that came with it clearly isn't intended for the overseas market because that's all Chinese. Okay, so this is the item on eBay. Now, we should probably go to the price first because you can't help noticing that this is not cheap. It's $45.85. Yes, that's right, $45. Free shipping. Now, this came from Alice Happy 858, and it's described as a 0 to 24 volt, 85 watt external power bank, backup 18650 battery charger for cell phone, laptop. It takes 8 18650s. It also has the LTC 3780 chip in it, which is a buck boost of that rather interesting new topology. And that's really part of what attracted me to this, so I'll definitely open it up at some point. In fact, I'm almost tempted to open it up now because I want to see the battery layout, because there is some complication with the batteries. So further down the listing we have some photos, front and back. Now there's some spec here. This says in DC is 18 volts to 20 volts, which seems like a rather narrow range, but the idea is that you plug a standard laptop power supply into this, and they're typically 18 volts to 20 volts, around 19 some of them, and that means that this thing will charge quite quickly. But you can also use the in USB micro 5 volts, which of course will charge at about a quarter of the rate, similar sort of current range, 2.5 amps, but less voltage, of course. The output is 0.1 volts to 16 volts, 17 to 19, 20 to 21. This is giving different current ranges for each of those voltages. It's dropping from 5 amps at the low voltages down to 3.69 at 23 to 24 volts. I think it is continuously variable. We won't see that until we switch the thing on. And then there are 2 USB outputs with a total of 2.9 amps max. But look down here. Here's the LTC 3780 chip. We've seen that before on the buck boost converter boards. It also has a balanced charge circuit here. So the cells, I believe, are in a series parallel arrangement in pairs. So it's actually 4S2P, I believe that's what it is. And then further down it talks about using high quality batteries. Now you wouldn't want to put useless batteries in this thing. Here's an activation hole and the ports. Now I seem to remember reading something about putting the cells in sequence. I think it was on an AliExpress listing. And you can see here it's saying 1, 2, 3, 4, and it's 1, 2, 3, 4. So we start top right, and then we put the other 3 cells in sequence. Now, is that something to do with the fact that the balanced charging system is monitoring the order in which they're being put in? I don't know, but I think I'll follow that sequence. But I only have 4 of these cells. I believe these are paralleled. So I'm going to put 4 in. Absolutely going to get the polarity right this time, because I don't want to blow this one up. And see if we can run this off 4 cells. Certainly won't be able to draw the maximum amount of current from it with only 4 cells in it, but let's give it a go. Right, I'm going to put them in with my numbers following the sequence that they advised. Right, minus up there with the spring, plus down there. That can't really be wrong, can it? Okay, that's number 1. Number 2 is this one down here again, minus where the spring is. So that's number 2. Number 3 goes the other way. Minus, oh, wait a minute. Yeah, minus down here with the spring. Plus is up there. Number 3. And number 4 is there. Minus. Trouble is, because of the curve on here, you get sort of shadow lines which add a sort of additional line to the negative, and in some lights it looks like a positive. So it's all a bit scary, really. Okay, cell number 4 goes in like that. Now I believe, actually let's put the back on, but then I think I've got to do an activation. So the back is on, and pressing the on button doesn't do anything, so I think we need to poke something in the activation hole. Paper clip. Yeah, that made a click. And that's on. Okay, let's look at the display. Right, well, what's it telling me? 62% charged, those cells. We've got 12 volts out on 1, 5.25 volts out on, no, 12 volts out on M, 5.29 on 1, and 5.25 on 2. So I think it's showing me the voltages on the 2 USBs and the voltage on the multi-voltage output, which is currently set to 12. This is a bit confusing. It's saying 10.8 volts out on M, and if I press down, it momentarily says 15.3 volts out on 2, I think it is. Is that USB output 2? Output 1? That's all a bit weird. Right, I've been playing around with this for a while and trying to understand the manual, and it seems that when you're drawing current from this device, you can't change the voltage. So I've changed it to 8 volts. I've got some bulbs here. If I put that on the multi-voltage output, they're quite dim, but I now can't. It appears that the on button is a plus button and the off button, the down button is a down button. I can't adjust that multi-voltage output while it's drawing a current. If I take that out, I can. It goes up to 8.1, 8.2, and if you press and hold, it jumps up in whole volts. So let's take that up to 14 volts, which is a little high for those bulbs, but it'll be fine. So 14.2, then down 2 to bring it into 14. One thing I have worked out is if you press both buttons, you get the selection for auto switch off and both buttons not switch off. So I've put it in the not switch off. There it is, look, 14 volts on the multi-voltage output. So yeah, that's right, but no, I can't fathom the user interface on this. And if it's non-intuitive, it's not the sort of thing you jump to buy, is it? Maybe once I work it all out, I can do a video on this. Some people are saying that it's not terribly accurate, and it seems that the sellers are actually saying the voltage and current readings may not be very accurate. We're doing our best sort of thing, which is slightly odd. Another thing is, in the manual, there are mentions of USB with QC 2.0. So it's possible that one of these USB outputs, and one is white and one is black, one of them can do QC 2.0 higher voltages. So it's all a bit confusing at the moment. The other thing I should say is it's probably okay to charge this with only 4 cells in it, as long as you only do it from the micro USB, because that's going to be a lower wattage, isn't it? I'm not sure how many amps it'll put into those cells. you probably wouldn't want to charge it from the 18 to 20 volts input, because I think that charges at a fixed 2 amps, and that's going to be too much for just a single cell. When you have 2 cells in parallel, 2 amps would be okay. Not sure about any of that actually either. Now I'm trying to take the 4 screws out, and I've got 3 out, but the 4th one, the head has completely rounded off because these seem to be made of very soft metal. So I'm having trouble getting that one out. I think I'm going to have to switch to a flat bladed screwdriver and try and sort of hold it in there while I force the screw out, but it's not going very well. Right, I'm inside the unit, but I did actually have to drill out that 4th screw, and there are now only 3 screws because it had to be basically drilled away to non-existence. But we're in, we can have a look at the chips and the balanced charging arrangement. So yes, these are parallel pairs of cells. It's a quite simple arrangement. There's a red wire there which goes down through these 2 cells. There's a thick black wire down here, and then it goes up through these cells, and then there's a black wire here. So that's the main power circuit. Then there's a small red wire, a white wire, and a small black wire to take off the tap points for the balanced charge measurement. And I'll close in on that PCB. And you can see here there are some voltages, 0 volts, 4V2, 8V4, 12V6, and I presume that's 16V8. So those are the voltages with fully charged cells, and these are the balance switches, I presume. There's the LTC 3780. There's a chip here which says BM something on it. Now, is that some sort of battery management chip? That's quite interesting. The LCD is up here, and this looks like it's probably an LCD driver. The back of the board has the more powerful components on it. So this is the back of the board. There are lots of these low value resistors for measuring current, presumably. Lots of these, well, several of these fairly large MOSFETs. Now, of course, the LTC 3780, I think it's called, has this quadrature MOSFET thing. So maybe these are the 4 main MOSFETs for that chip. There's a fairly chunky inductor here, not many turns, but it's quite a hefty thing. And then several other inductors doing various jobs. I'm not going to go into a huge amount of detail now, but yeah, that's the underside of the board. And possibly one of these USB sockets is Quick Charge 2 compatible. Right, I found some replacement screws. So I'm using 2 of the original ones and 2 new ones. They're not quite the same length, but it doesn't matter. So I'm going to put this all back together again and just spend some time trying to fathom out this display. And there's no point doing any more in this Postbag because it will just go on forever if I do. I'll need to do a video on this unit all on its own, I think. My gut feeling at the moment is that it's not really going to displace the QD184 as my favourite power bank. So I think I'm going to have to try and get hold of a QD185 with the multi-voltage output to see if I can displace this. And these are today's Postbag items. And a big thanks, as usual, to Patreon donators who make Postbags possible. And I will try not to make a habit of buying $45 power banks. Cheerio.